All right, good afternoon, everyone, and welcome to the Best Tutorial Track. I'm Lee Lacey from SOAR Technology. I'm a member of the Tutorial Board, and I'm the chair of the Best Tutorial Committee. I'm chairing this session, and the deputy chair for this particular tutorial is Dr. Charles Cohen in the back from Cybernet. He's going to be helping with surveys. We're going to be passing those out, and we'd appreciate it if you'd either fill it out online or fill in one of these and hand it to us as you leave the room. A few announcements as a courtesy to our presenters. Please turn off or silence your cell phones. The presenters are going to have 80 minutes for their presentation, followed by 10 minutes for Q&A. So please hold your questions to the end of their presentation. If you need to leave before the presentation's over, please use the doors in the back and not the door on the side. And there is no flash photography or video recording, but feel free to take some still photos and to post them on social media. As a reminder, to get the CEU credits, you need to be scanned when you come in the door. And also, later today, I've been asked to remind people that at 4 o'clock is the ITSEC Fellows presentation. That's in room 330 ABCD, and Dr. Wink Bennett will be presenting. So this track today is of the best tutorial nominees. Out of the 33 tutorials at ITSEC this year, these 3 were selected as candidates for the Best Tutorial Award that'll be presented at Thursday night's banquet. There's seats over here, about 5 or 10, and some up here on the front row and second row. So this third presentation is number 26, Unleashing the Potential, Harnessing Large Language Models and Generative AI in Military and Industry Applications. The 2 presenters are Dr. Ramona Shires and Dr. Robert McCormick. Dr. Shires is a senior instructional systems designer at Aptima. She holds a doctorate in naturopathic medicine from National University of Health Sciences, an MA in education, leadership, instructional technology, and a BA in elementary ed from University of West Florida. She has more than 40 years of experience in the analysis, design, development, delivery, and management of public school, university, nonprofit, commercial, DoD, and international education and training programs. She is an expert in the ADDIE model and ISD. She helped to develop Nautical, the novel AI utility for training, instruction, and comprehensive analytic learning, which is an AI assistant for training development that utilizes large language models, such as ChatGPT, to aid instructional system designers. She has served in several leadership, program, and tutorial subcommittees for ITSEC, where she served as the 2014 Education Subcommittee Chair. Her co-presenter is Dr. Robert McCormick, who holds a PhD in math from Texas Tech University and currently serves as the Division Director of Intelligent Performance Analytics at Aptima. With a strong focus on generative AI, Dr. McCormick is recognized for developing innovative applications tailored to military needs. His extensive project leadership includes serving as a principal investigator on DARPA-sponsored initiatives, where he explored the simulation of online discourse to test interventions aimed at promoting civil communication. Additionally, he contributed as engineering manager on the Nautical project, which leverages retrieval augmented generation, or RAG, workflows to support training development analyses for the U.S. Navy. Please join me in welcoming Dr. Shires.
Good afternoon. First of all, thank you all for coming. I'm very excited to present along with Dr. Shires on some exciting new uses of generative AI. Before you get confused and say, like, why are there a perfect picture of them presenting right now, this is just one of the many fun uses of generative AI, generating images, and really, you know, any sort of data modality out there, there's probably a large model for being able to generate it and understand it. But today we're going to delve into kind of how generative AI technologies are beginning to revolutionize training and education, both in the military, across industry, really across the world. And we live in very exciting times now where new models are constantly being developed, new applications of them. So, you know, there's a lot still to learn out there, and we hope to give you some kind of some tips and pointers on where to start your journey into generative AI. Okay, so we have a number of learning objectives that we hope you get out of the session today. So the first one is really understand, how do you select an appropriate AI, large language model, image model, whatever your need is. How do you go about choosing which one to use? So what are the criteria you should consider? What are kind of the technical, software, hardware constraints or prerequisites that are necessary for implementing generative AI-based solutions? We'll talk a bit about the methodologies and rationale employed for selecting, designing, testing, and validating large language models. And we'll explain how AI large language models can enhance the efficiency of specifically the instructional system design process within military training environments. And we'll talk about potential integration challenges and barriers and things you may come across as you begin to develop solutions using generative AI. And one last one that's not up here. I want to ask a question. Who here has never used generative AI? See a couple hands. Well, that's okay. So my one ask is everyone leaving here today, go and just sign up for a free account on ChatGPT or Anthropic and just try out. Ask it to write you a joke. Ask it to write you a poem. Play around with it. See how it reacts to different prompts. That's really the first step, is just go out and try it. And we have some kind of practical exercises throughout the tutorial that you can take and try. You can use the exact prompts that we use and see what the results are. And that's a great way to start, is just by doing it. Okay, so I'm not going to go through this list, but there's lots of terms and jargon and words that we're going to be using throughout the day. Here's a few of them, but if anything comes up, feel free for ask clarification at the end. Okay, so I want to start by really giving a brief history of artificial intelligence. So 100 years ago, there were things called computers, but do you know what the computers were? Humans, probably women, sitting in big rooms at typewriters and with pen and paper doing calculations. But once digital, analog and digital computers started to come online, AI kind of was brought up right along with it. So beginning in the 40s, Alan Turing developed a Turing test to differentiate, how do we differentiate a human and AI? There was early work in things called perceptrons, which were like analog circuits that really kind of evolved in spirit to today's neural networks. Eliza, some of you may have played with Eliza, was an early chatbot that could actually respond in English language to questions and prompts that was given to it. So there was a lot of early work from the 40s to the 70s. From the 70s to the 90s, there was something called the AI winters. This is, there was diminished interest in AI. A lot of the promise was not proving out yet, so people stopped using it. There was, still research and development going on, but not a lot of application of it. And some of the limits in computing power really kind of presented roadblocks to continued development. But then in the 1990s and forward, there was a lot of breakthroughs in machine learning algorithms, statistical processing, and increases in computing power. And some of you may be old enough to remember when IBM's Deep Blue beat Kasparov at chess. That was a huge accomplishment for AI. A lot of people thought it could never be done, but lo and behold, you can probably get a thing on your phone that can beat you at chess now. Certainly can beat me. Okay, and then, in the last really 10, 15 years, we've seen an explosion in the era of big data. So, with the internet, we have a lot of data out there now. We have access to cheap information. We can scrape and pull from thousands of different websites. Along with that, a lot of advances in deep learning. So these are multi-layered neural networks, and I'm not going to go into detail on them, but they can do a lot of different things, and they can learn from that data. And one of the big breakthroughs that empowered generative AI were things called transformers. So there was a paper out of Google in 2017 called Attention is All You Need. And that laid out the architecture for what are called transformers, which turned into what we now know as general pre-trained transformers, or GPTs, which are the basis for a lot of different language models out there. So what is a language model? A language model, in simple terms, it's a machine learning model designed to predict and generate plausible language. You've likely encountered a basic version of this in something as simple as autocomplete on your phone or a computer. But we have large language models, which are a step further than just a language model. These models aren't just for simple tasks. They're designed for general purpose language understanding and generation. LLMs achieve this by processing massive amounts of data, learning from billions of parameters during training. And of course, all this requires significant computing resources, both during training and operation. If you saw Say's tutorial this morning, I believe she talked about training ChatGPT 3 costs something like $64 million. So they're not cheap, but once they're trained, they're very powerful. So why do I want to use a large language model? So specifically in training, they can aid in developing customized training programs and educational content. By tailoring simulations and training artifacts to specific learning objectives and specific learners at different skill levels, we can ensure more targeted and effective learning experiences. These models can also offer adaptive responses. So instead of just a canned response for an action that a trainee may take, they can simulate intelligent adversaries or allies. They can provide trainees with dynamic and unpredictable interactions to really force learning. And this only makes training more engaging, but also helps to improve strategic thinking and decision-making skills. Third, large language models can lead to cost-effective training solutions. By reducing the need for physical resources and personnel, they offer scalable and efficient ways to implement comprehensive training programs. This makes them particularly useful in scenarios where resources are limited. Finally, language models can enhance communication skills. Through realistic communication exercises, trainees can practice conveying and interpreting information accurately, which is crucial in high stakes or uncertain conditions. These benefits combined make language models a powerful asset in modern training environments. Okay, so what are some factors you should consider when choosing which large language model to use? So first of all, domain expertise. There's a lot of models out there that are specialized, specially fine-tuned on particular training data sets. So for example, there's medical chatbots out there that are trained on medical knowledge. Same with legal or other technical areas. And so you want to choose one that aligns really with the domain that you're using. Things like ChatGPT, they're general pre-trained models, so they have a lot of general knowledge and really know how to speak and interact with humans, as well as the task type. So, if your task involves text generation, maybe it involves summarization, so taking a large document and providing a summary for it, translating from one language to another, or answering questions. These are all kind of considerations you should think about before choosing a model. Performance versus resources is another trade-off. So you need to figure out what is the right size model for my application. These are not free to use for bigger applications. So you want to choose one that is the right size, right cost for your application. Latency requirements. So some models perform really well. They'll give you an instant response. Others maybe have to think for a minute. And maybe that's okay in some applications, but another thing to consider. Okay, so other things to think about: cost and licensing. So you want to evaluate the cost implications for commercial large language models. There are open source ones out there, but they may require some additional tuning. You may need your own hardware, or you may have to get cloud space to host those on. Licensing terms too. You need to look at, what am I allowed to do with this model? Can I actually embed it in an application, or does it have to be separate? Ethical considerations, so bias and fairness. Assessing the model for potential biases to ensure it aligns with ethical standards of your application. So models, large language models, are only as good as the data that they're trained on. So any inherent bias in that training data is going to show up in your output data. Say gave a great example this morning about how early Amazon resumes were all male, employees were all male. So building a hiring system off that set of resumes, it's going to be biased towards men. So you really need to understand how the model was trained and what potential biases may be in there. Explainability is another consideration too. Can this model not only give me an answer, but can it explain why that answer is true? And you also want to look at kind of the community around the models out there. Is there enough support, documentation, people using these models to help me answer questions? And what other applications have these been embedded in? What other tools built around large language models can I use in my application? So all things to consider. When you're looking at specific models, I put some of the parameters of these models up here. And these, when we wrote these over the summer, these were accurate. Of course, 6 months has passed now, so I'm sure these could be updated with newer models, different specs on them. But these are just some examples. So the ones we were looking at specifically were a couple different versions of GPT, ChatGPT, 3.5 and 4.0, Anthropic's Claude 3, and Meta's Llama 3. So Anthropic and OpenAI, they both have commercial models that you can use and license and put in your applications. Meta is an open source model. So that's one where you can self-host. So if you need to bring a model into a closed environment off the internet, well, that's one possibility, is to take an open source model, host it yourself in your own environment so you can have access to it. Another thing to think about is context or window size. So how much information can you actually put in a prompt? Early models had window sizes of a couple hundred tokens or words. Now we have up to 1 million or more words that can go in that. And you might say, like, well, why would I ever want to write a prompt? I'm not going to write out a 1 million word prompt. But some of the techniques we're going to go through, like retrieval augmented generation, you're bringing a lot of data into that prompt to provide context for the questions you're asking. So you really do need to consider, like, how big of a document can I upload to this model to power my application. Okay, other things to think about is, again, the whole ecosystem of other tools you're going to bring to this model. Unless you just want a chatbot that you can put out there like ChatGPT has, you're probably going to be building tools that go around the model. So you want to have LLMs that have an API so that other programs can access them. You want to think about what are the other services around that. So things like Docker is a tool to kind of easily transport models between different computing systems. OpenSearch is one framework for storing prompt data, for example. Web framework for building applications. Vector databases can help store data and help search for that data to bring it into prompts. You also want to think about some of the hardware requirements. So some of the small models now are able to run on a laptop, even a phone now for some of the smaller models. And of course, Apple and other companies are building those into phones. But some of the larger models require kind of massive server farms to run. So you need to think about kind of what's the right size for your application, what's the right infrastructure, et cetera. All right, so I won't go through all this, but you'll have access to these slides after the presentation, just some other considerations in terms of GPUs, memory, storage that you may want to think about when you're developing an application. Okay, so I'm just going to kind of speed through some of these. And I'll hand it over to Ramona.
Thanks, Bob. So that's a lot of information on the hardware and software, the considerations that you're going to have. So we're going to get into, I'm going to talk about prompt engineering and product items and start into how do you start talking to these things. So the first one, I'm going to explain what we call a product item. When we were starting to build and using large language models, we had to come up with a term, but what do we call all these data points that we're generating? So we came up with a product item because it's simply an item, a piece of data that you're generating that's being produced. Now, I might have a report or analysis fields with different data elements. I could have training scenarios that have different elements of what's going on in the training scenario. Each one of those things that I'm producing is simply a product item. So when we look at each product item, it's dependent upon the data inputs that we use to generate that product item, the desired output. Of course, for instructional analysis or design data is important for LLMs to use along with military doctrines, publications, manuals, all this other kind of input. Other military data such as JDTAs, SOPs, any other kind of things will feed in, and that's what Bob alluded to, is when you're looking at feeding in a lot of that data, the prompt or the information that you're sending it for it to be processed can get quite large. Can you imagine sending in a whole, SOP into that, plus a whole lot of other questions? So LLMs also require, they rely on lookup tables and reference data, such as tables, methods, criterias, formats, and all of this kind of information to help guide the development process. And then there are data sources and repositories that could be both internal or external, like databases, online knowledge bases, or other things that store essential information that's critical for you producing the response that you want. Additionally, there are dependencies and relationships between data elements. And these inter-item dependencies and contextual information help ensure that everything aligns correctly and that functions as you're intended and you're getting the responses that you're looking for. Let there be light, everybody. And I'm going to pause for a second because I work on the committee. So anybody that wants to scoot over and let these people come sit, come let them sit down. It's going to be a while. Okay. So what do we do also with these product items is we want to enhance the responses we get. And what we decided to do was kind of go with a structured approach to this. So not only do we have this external data sources and other databases that we're hitting, and the lookup tables and other references that we need. So when we're looking at an ISD and I'm looking at doing a training analysis or whatever, some of these fields, options, scale items, these things are prescribed already. So if anybody's an ISD out there or working in training analysis, I know a few of you are, you'll recognize that statement. And so what we did is looked at a structured prompting approach. There's an example of it on the right-hand side of the screen. So this method enhances the LLM's responses by systematically incorporating relevant data, well-defined templates, and clear formatting instructions. The example on the right demonstrates that structured approach. It guides the LLM by specifying task descriptions, examples, and context options for generating an appropriate response. This approach ensures that outputs are accurate, relevant, and aligned to specific instructional requirements. Can I have my water? Thank you. Too much talking. So I want to talk to you a little bit about prompt engineering. This is, as an instructional designer, something I had to learn, and this is what I do on a daily basis. He deals with the hardware and the software and all the other stuff in the background. I'm the front-facing person talking to it all the time. So prompt engineering uses statements that guide the AI. These statements, that's the request that you put in when you play around with ChatGPT. Can you tell me how to do this? Can you generate this? Can you rewrite this paragraph for me in a nice format and well-written that I can't do on my own? So it involves crafting those statements or queries and to guide the output. The process isn't simply about asking a question. It's about using specific techniques and best practices to improve how the AI can handle the natural language processing tasks. And there are several key elements involved in prompt engineering. First, phrasing your query. You really want to phrase it in such a way that the AI can best understand it and respond to it. And that's what Bob alluded to. You know, just playing around with it and seeing how it responds helps you understand how to talk to it. Kind of like every other relationship we have, right? So this might involve a particular style or providing it with relevant context and clear directions. One of the things that you see at the bottom there is, I am an instructional designer. So when I tell it I'm an instructional designer, it's going to color the response based on my job role and what I want it to do for me and what the output is supposed to be. If I was a marketing director, it would be completely different, right? You know. So let's talk about basic prompt writing and structuring. So the prompts do guide the input, and they determine the context, the tone, and the scope of the output. What do you want out of the system? And there's some basic components to that. First of all, you have to tell it what's the task. A task clearly defines what you want the AI to accomplish. You give it instructions. Say, provide explicit instructions to guide the response so that it knows exactly what it's supposed to do. You have to provide it context. That sets the background or situation of which you want this to be performed or how you want it to generate the response. And then input. The input, you have to give it the right data. You have to give it the information that it needs to actually produce the information that you're looking for. And then parameters. Those are some things like within this, don't do this, do this, ask it like this, give it to me in a single option, give it to me in a paragraph form. How do you want this to come about? All right, so these are some elements that we worked on in our structured approach. We took a lot of the information that we had and kind of looked at it in a general format and tried to see how we could put it into buckets of information to feed into the system, okay? So first one was in the instructions, we provide it with a definition sometimes so that it provides clarity to the system. Sometimes, for instance, if I'm talking about audio fidelity, if I'm talking about it in an aircraft or in a situation, it's going to be different than if I'm talking about a recording studio, right? That's a whole different game. We have to provide it criteria. So how do we self-assess the adequacy of the response? It needs to know what is the criteria I need to use. And then some of the things for instructional design and training analysis, there are very specific criteria, especially in the military environments, very specific criteria. Constraints. Are there some things that are different? So for instance, we've worked in using construction electrician stuff. You'll see an example of it later. And that, if you look at it in a civilian environment, it's going to be completely different than if you're talking about the Seabees, okay? So giving it constraints of it's going to be this kind of environment and in this kind of context plays an important role. A lot of times the system will provide you a better response if you give it an example. So if you say, I want it to look like this, I want it to sound like this, and let me give you an example of that. It does a much better job of providing you with the response that you're looking for. Again, options and scales, if they're predefined, you give that information to the system as well. And then how do you want it formatted? Do you want it in a paragraph? Do I want a single list, comma delimited? How do I want that? Some other elements of the basic prompt is task. What do you want it to do? So you give it a query. What am I asking you to do? Then you give it a command, an action verb. Determine whether it's something. Provide this information. Write this information, whatever that verb might be. What is the topic? For instance, I'm doing a learning objectives analysis. Okay, well, that's different than a task analysis. So the output would be different, and the way they would process the data would be different. And then role. Roles are really, really important in using language models. They really help guide because that system kind of has a job description already in there somewhere. And it knows the difference between an instructional designer, a marketing director, a training manager, a fleet commander, whatever that might be. So that's a really good thing to remember. Always start with, I am a blank, and I need blank. So context matters. The way you frame that prompt is going to be completely critical on what you get back out of the system. So a couple of things to consider here is purpose. What is the reason that you're asking for this information? What outcome are you aiming for? What's your perspective? For instance, like environmental considerations, nighttime operations, military operations. I'm a part of a crew, part of an air crew or something. The supplementary information, so additional details that are needed for accuracy and clarity to the system. These could be reference documents, other data sources, or even previous responses. And then target audience. This is important too, just by defining the role, it knowing where the information and who's going to use this information is important. Is it military? Is it a training organization? Is it leadership? Those are all different audiences. The next part of a basic prompt is parameters. Some of these are starting to get advanced, and we're trying to stay at a pretty basic level today for more of an intro, so I'm going to go over these. But definitely, you have to tell it what model to use. In some of the work that we do, we actually are able to use different models because, as you saw earlier, they each have their strengths and weaknesses. So we might use one model for one type of data, different model for something else, especially with the tokens and the amount of information that you can feed it. Temperature. This is an interesting one. So when you're playing around, you can then actually change the temperature. It's a 0 to 1 parameter. And that, if you want your data really finite, you don't want it to be very creative, you turn that temperature down to 0. Or some smaller number. But if you want it to be wildly creative and come up with things that maybe you didn't think of, then you can turn it up and it'll be more creative in its response. The length, again, you want to tell it. For instance, let's say you were doing something for a presentation and you wanted something to like, okay, I'm going to do so many slides and I want every slide to only be 2 minutes long, and you write me a script for it. It could do that because I gave it 2 minutes long, so it knows how long the text would be and it would be able to use that. And then some other advanced parameters that you could give it a penalty if you don't want a certain output and it gave it to you, or the likelihood of unwanted outputs. So, we told you we were going to give you some try-me's. These are ones that you can, everybody's taking a picture. You can take a picture and do it now, but you can also download these slides later. But I'm going to go through this one. This is taking all of those together, and all the bold text are where those elements are. So as an instructional systems designer, I'm performing a task analysis. I'm telling it what I'm doing. For what? Oh, for a particular rating construction electrician. I need to determine, there's my action verb, the difficulty of performance. And to do that, consider this definition. And I give it that specific definition. I don't want it to make things up. On this instance, because it's very finite and very prescribed, I'm going to give it that definition. And then provide it in a military environment in that context and use these options, and I tell it how to do the response. So this is a sample of a prompt that we would use to generate one of those product items. So now you got all that, and you're like, okay, I'm trying this out, and I'm putting in all my information, but what are some mistakes that I might make? Well, one, being too vague. You've got to be very specific. It can't read your mind. We want it to. It's not quite there yet, but one day maybe. But right now, we have to be very specific. Also, don't make assumptions about the knowledge that it has. It can't infer context that you don't clearly define to it. Sometimes I go in and I say, tell me what you know about this. And it'll tell you, I know this, this, and this, and I know this and this. Okay, great. Now I know what I can use to work with. Avoid using jargon or highly technical language unless you give it a reference, because it may not understand it. Okay? And then you have to provide feedback. So if you use ChatGPT, that's that thumbs up, thumbs down, I liked the response on it kind of thing that you see. But we also, when we're making these things for use in other applications, we actually have feedback inputs where we can say, yes, that was a good answer, or no, we don't really like that, change it and take this information, you got this part right, but maybe not that part. Okay. So that's a basic prompting information. So let's look at some advanced prompting techniques. So for instance, chain of thought. Chain of thought prompting is where you break down a complex task into smaller steps. So do this, then do that, then do this, then do that, and then give me the answer. And we've got some, I'm going to go through some samples of every one of these. Few shot, you give it a couple of examples and say, hey, what can you give me back? Constraint, that is when you give it a certain set of constraints, and it absolutely must meet every one of those constraints, for instance. Is that going again? And then meta prompting. Meta prompting is kind of my favorite, because that's where you actually ask it to help you determine how to write the prompt. So sometimes I say, okay, it's not giving it to me in the paragraph format that I want. So I can say, I'm trying to do this, but can you help me do this better? How can I ask you to do this? How can I ask you to give me a comma delimited list? And then it'll say, well, try writing it like this. And it'll give it right to you. So basic chain of thought prompting. Again, I've got samples here so you can see. What does this do for you? What's the benefit of using this approach? Well, first of all, it increases transparency, which helps in debugging logic errors and identifying any biases in the response. So a lot of times when it's kind of I'm an elementary school teacher, I was at one point. It's kind of like the whole show me your work aspect, you know, because then you can see where the logic went awry. Okay, y'all are going to make me dizzy here. I don't know whether to go for last call or what. I don't know. Trust. So building trust, when you can see it lay out and it explain to you how it got to that response, then you can test that logic and say, yes, that looks like the appropriate response. I have more trust in that. Accuracy and reliability. Breaking down those tasks into smaller steps helps it do it more accurately. It doesn't have to infer how it gets from point A to point Z. You're going to help it along the way. Also, it can reduce time and development costs, because if you're trying to figure out why it did something incorrectly, not the way that you wanted it, if it explains it out to you and shows you the rationale, you can easily pinpoint where you may have gone wrong in your prompt, or you didn't feed it enough information. Again, here's an example of a chain of thought. And so focus on use this thought process, and you can see I'm telling the system what to do every step of the way. Use this, use that, add 2 plus 2, then divide by 4, kind of thing, strategy going through that thing. And then also how to provide the response in a way that I want it to respond very succinctly, so that I know I'm going to get the information out that I want. Meta prompting. So one of the things, again, is as you're learning to write prompts, we can use the system to help us get better at it. So you create an initial prompt or question, and then you can interact with that large language model to optimize it. How do I write this better? I'm not getting exactly what I want. It's kind of close, but I know I'm missing something. and you can actually just ask it, okay? And then incorporate the feedback with the system saying, yeah, I liked the first part of that one, but the second and the third parts, wasn't quite off. I need it to be more specific in this area. And then it will then give you a better response. You try that one, and it's an iterative process where you have to go through it sometimes over and over, but it will help you with your prompting. So again, here's one that I actually did. On the left-hand side, that was the prompt I gave it, and I said, I have this answer, but it's not exactly what I want. And then how can I stop you from giving me a lead-in? So anybody who's done any prompt engineering, it'll say, well, to answer your response, I have come up with the following. Well, I don't want that. I don't want you to tell me, just give me the answer. Skip the lead-in. So this was when I was like, how do I stop you from doing that? So that was the response, and I said, well, give me the details and tell me not to do it. Okay. So I went right on through, and that's what you can do with meta prompting. Again, now here's some other ones, some other try-me's. So what are some examples? I asked it for some examples of some things that it could do, and it gave me a whole list of things it could do and how to then ask for those things. So it really is my assistant a lot of times. So we have a system we work and we build things in, but I also have another helper app over to the side that says, how do I do this better? How do I become a better prompt engineer? And another one, I'm using a specific API. So each one of these large language models has different things about them, different ways it's going to process. So by, again, giving it context of which one and that I'm using the API version actually makes a difference. So I want to format these responses. How do I format them? How can I do this? And it gave me a whole list of options, which we're going to look at for a few minutes, of ways I could properly format those responses. So for some of you that may be programmers and are probably, how many people in here are using it to generate code? And your bosses won't look. Close your eyes, bosses. Okay, thank you. That's a pretty good amount. So it does really good at helping with coding now. You can provide, it can give you post-processing scripts to look at the data it generated and make corrections before it actually gives you the final response. You can modify your outputs so that they give you fonts and colors and alignments. You could have it do markup and those sorts of things. And so this is one way you can ask it to help you with that. A lot of them do use Python. You can have it do HTML. You can tell it what you want, JavaScript, whatever. It'll format it in the way you want. Markdown. I use Markdown a lot, actually. So Markdown, if your API and your large language model supports it, it allows you to structure the text with headers, lists, and other formatting elements. So a lot of times in the ISD work, we have all these lookup tables that we have to reference and other data tables and information, costing tables, budget tables, you name it. And so this is a really good way to have it formatted in a way that it could easily find the answer and keep it structured for you. HTML, so if you're writing web pages or you're formatting documents or other things, HTML can come in really handy. Using that with inline CSS, cascading style sheets for formatting and color selections would really help you get a good output, especially if you're generating reports and things. So I want to leave you with a couple of tips here on prompt engineering, on how to improve your prompt engineering. So first of all, understand what AI is and what it can do. And then how each of these models work. Okay, so do some research, read some books, take a course. Coursera, I'm not pitching for Coursera, but Coursera has a free course out there in prompt engineering. So you can learn a little bit more about it. Know the strengths and weaknesses of the LLMs that you're working with, because each one of these actually does have different parameters. They work differently. So know that you're using the right one for the task that you're doing. Practice, practice, practice. I started prompt engineering beginning of last year, and I am substantially better than I was last year. I call her Charlene, I had to do it. ChatGPT doesn't roll off the tongue real easy, so I call her Charlene, and I can get her to do just about anything I want for me. So it's just really nice. And then test them in real world scenarios. So although I've given you some try me's, you test them in your job and take the elements and try to make sure when you're writing your prompts that you're getting all of those elements into your prompts. You'll see a difference in the responses that you get. Okay. So, is this where you put it? No. Yeah. All right, I'm going to hand this over to Bob, and he's going to start talking data stuff again. So.
Thanks, Ramona. Data, my favorite thing. So why is data important? So, I've got ChatGPT. It knows everything about everything in the world. Well, not quite, especially for specific applications, military applications. Some of that data may be classified. It may be CUI type data. So how do I provide that information to the model through the prompt is what we're looking at. So there's a few different considerations that you want to look at when you're choosing and curating your data sources for your application. So first, why is it important? So enhanced accuracy. So the more information you provide to the model, the better the answers you're going to get back. Providing context helps it differentiate between different scenarios, different words have different meanings, so providing that enough context so it can understand the question you're asking is super important. Lookup tables, as Ramona said, especially when you're doing kind of very specific work in training analysis, things like that, you have a lot of lookup tables. So you need to be able to quickly reference those. And you can put those as part of the prompts through markdown formatting or other ways. But providing that information so the model can find what it needs to when it needs to. And this all requires making sure that you clean your data, make it available, make it easily searchable, and be able to retrieve it very quickly when the prompt needs that information. And so one of the best use cases for why you need to have clean data sources is a process called retrieval augmented generation, or RAG. So what is RAG? So RAG is a way of providing that contextual information without going and having to retrain a model or fine-tune a model on specific knowledge. You can bring that knowledge into the prompt. So RAG kind of sits on top of large language models and provides that context that you need. So assuming you have a database of curated information that you want to use with your large language model, the first step is retrieval. So just finding the right information to bring into your prompt. And there's different ways you can do this. You can use vector databases to store that information and retrieve based on keywords. You can use more advanced data models like knowledge graphs to help structure that data and bring it in. But you want to be able to quickly search and retrieve the data you need to provide context to the prompt. Refinement. So this is, taking the data and making sure that the data extracted is relevant to the prompt. So this can require some iterations of going through the prompt, seeing the answer, maybe changing your search parameters, et cetera. And then the last step, generation. So that's finally where you're asking the model to actually generate a response based on that data you're bringing in and the question and the prompt that you're inputting. Another thing that we've kind of touched on but really haven't gone too deep into is multimodal generation. So large language models, or more generally foundational models, they go way beyond just text. They can generate images, and especially when you're doing training applications, creating multimedia presentations by creating images for that student at the right time to help illustrate a particular learning concept, for example. There's tools like DALL-E and Midjourney where you can put a text prompt in there and ask it to generate an image Code generation, sounds like a lot of you are already doing this, but I need a Python routine to quickly translate these coordinates from lat long to polar coordinates. So ChatGPT or other specially trained models can quickly create the code to do things like that. Agent behavior generation. So if I have a simulation and I want to tell my agent how to perform and how to behave in different contexts, these are starting to be integrated into those simulations to actually drive the agent behavior using generative AI models. So one thing, you never want to just trust the response from a generative AI system. They are very good at coming up with responses, even when it doesn't know the correct answer. So it will happily tell you what you want to hear. And if you just trust it, that could be a problem. So in order to, reduce hallucinations, to, make sure that you're getting accurate results out of your model, you want to constantly be validating it, making sure those responses are correct, going back and doing lookup. Once you've validated it, then you can release it into the wild to do its thing. But you really want to make sure that you kind of iterate on it, generate responses, make sure that they're accurate, and then deploy your application. Where a lot of the power of these models comes in is something we refer to as batch generation. But this is just simply like, sometimes you don't want to just ask it one question. You need to ask it 1,000 questions to be able to complete your analysis. And it's not just 1,000 independent questions. Question 7 might inform question 8. So you have a lot of dependencies in your data and in your questions there. So you need to make sure that if you're running a lot of prompts, that you understand those dependencies, you respect them, you can map them out, and that will determine the order in which you generate responses. So you want to be able to identify those dependencies before you generate. You can create kind of a dependency tree or dependency map that you iterate through as you generate. But you need to be able to kind of understand what those dependencies are before you do it. And then things like checkpointing. So what if I'm on response 899 of 900 and it crashes? You want to be able to recover that data so you can continue on with your batch processing. Okay, and I'm going to hand it back to Ramona one more time to go through a couple of case studies.
So we've given you a lot of information. I know it's fast and furious. You can download the slides later. But we want to talk to you about some case studies. How do you actually apply some of these? So the first one that we're going to talk about today was a use case where the NOC TSD put out a challenge to look at how AI and large language models could help automate ISD analysis and requirements development for the Ready Relevant Learning program. This was put out last year. It was kind of October through December of last year. So in that case study, what they wanted to do was to take their requirements phase where they do the task analysis, the training situation analysis, task analysis, learning analysis, media selection analysis, et cetera, and just taking those three that are with the orange numbers, looking at to see what's the art of the possible for using large language models with this. They wanted not only to actually generate the data for the task analysis and the learning analysis, media selection analysis, but also generate the output report documents as well, the IPRD and IMRD. So a system that was built in that challenge used these 4 elements. One is browser-based interfaces. It allowed the ISDs to create product items through templates, prompt execution, and data visualization. The interfaces also enable RAG and chain of thought workflows, which we covered earlier, for a more streamlined process. Second, expert prompt engineering techniques were used. This scalable approach adapts across different use cases, leading to significant cost savings. And you saw some of that in our structured prompts and the way we created fields and then reused that data in a very structured way. Robust models, data models. Again, there's a lot of information. You have to have a good, robust data model to be able to address, ingest, and then digest, and then respond with all that information. And then data and rationale. When we decided to do this, we realized that people were going to have to review these responses. And so it's kind of hard to see up there, but we took and did a little Excel magic. And as you hover over the spreadsheet to help the ISDs, the SMEs, and other people look at a data element like criticality of a task, they're like, why is it catastrophic? Well, they could actually hover over it and read the rationale. And sometimes, if anybody's out there, ISDs have ever worked with SMEs, and they look at things, they don't know everything, and they may miss a few things. And so sometimes we found that the system was actually coming up with some good things like cybersecurity issues and things that we hadn't really considered, and may not have missed during a data collection or a site visit. So we provided a way for them to be able to actually review the responses and why that was the item selected. Here's a couple of samples of the screens. On the left, you can see how the system captures dependencies, instructions, criteria, constraints, and all the data elements for each product item. And then on the right, you can see the prompt template options for configuring these sources, setting generation strategies, and also defining the prompt. You'll see the little slider, that's the little temperature window up there. We can change models that we're going to use and try out different models to get the best response. And then the screen in the middle highlights the review process of the generated response and allows us to generate over and over if we need to get the best response. It also allows for feedback to the system, again, to generate better responses. We were able to accomplish quite a bit with this system. As you can see by the blue bars, we got almost all of the ability to do the task analysis. There were some fields that had to be manual, or we didn't have that information. Same thing for the learning analysis. And we got a good way on some of the other products as well. So another use case for this for using large language models is for document development. This main objective of this exact project here, creating RFPs with AI human functional teaming, was to leverage the powerful capabilities of LLMs and RAG to swiftly generate clear and relevant text from years of accumulated projects and intellectual property, including past proposals, reports, resumes, and all that to inform new document generation. I've worked a lot of proposals, and just going through all that stuff is a nightmare sometimes, or trying to find stuff, so this was really good. The result of the system allows users to produce high-quality, contextually rich documents, such as RFPs, saving time and improving the overall quality of professional writing. I know somebody was here early in the morning and said they didn't want to see AI-generated proposals, but past performance and other good data items, there's a lot of good content that could be generated automatically versus human. So, writing proposals, reports, and papers is a common task in all of our industries here. They require careful structuring and clarity to ensure that they meet high standards. And the LLMs can play a crucial role in streamlining this process. It can generate human-like text that aids in creating structured and coherent documents. LLMs can help produce drafts and final documents more efficiently, ensuring that the work is both comprehensive and clear. And then also it can streamline the entire writing process, allowing for faster creation while maintaining high quality and consistent outputs. Some of the benefits was, first, efficiency. LLMs facilitate rapid initial drafts, and that can speed up the document creation process. Getting to pink team faster, everybody. By reducing the time spent on writing and editing, the LLMs allow professionals to focus on the critical aspects of the work, enhancing productivity across the team. The next thing was quality. They can help minimize mistakes by providing suggestions based on learned patterns and data, ensuring high accuracy in the final documents. And also, LLMs are adept at generating concise summaries and overviews, which are useful for writing sections like executive summaries and such. Customization. Using personas, LLMs can adapt the generated content to meet specific needs of different audiences, ensuring the document resonates with its intended readers. And then after reviews, it could easily incorporate new information or changes, allowing documents to be updated swiftly without needing to rewrite large sections manually. How many people in here actually participate in proposal writing? Curious. Okay, yeah, a lot of us. Okay. So some of the use cases for document creation, again, proposal writing. You could create reusable templates, allowing for consistent formatting and structure across most proposals. Most companies do sort of have their flavor of how they generate these sections, their tables, their features and benefits, all of that. Section automation enables rapid generation of common sections, such as summaries and budgets. Report writing. AI enhances report writing by allowing for seamless data integration, including charts, graphs, and analyses into these reports that make them more comprehensive. And then consistency through uniform formatting and structure is crucial for clarity and professionalism. Research, you can quickly gather relevant literature and data for research tasks, making that process much faster. And the summarization capabilities it has could help researchers distill complex information into concise key points for better understanding and communication. Drafting and editing, again, initial drafts can get there quicker, and with real-time edits, you can allow users to make adjustments easier. Our final case study focuses on the use of AI for training content development, and this was specifically for the U.S. Army at Fort Moore and the Maneuver Center of Excellence. They were faced with developing data literacy courses for 3 learning levels, basic, intermediate, and senior, across 14 different ratings. You can imagine how difficult that was going to be. So they were concerned, first of all, about how well the AI process would align to their existing training development capability, their TDC platform and system. So first thing we did was we mapped it out. We took our process here and showed them where we would extract from and inject our processes and the information and data. So these are the fun examples that I really enjoyed to show everybody. First, we were able to demonstrate how AI could create detailed lesson plans. This is the same content, basically, but it's adapted by the persona, by the rating, and by the level. So you'll see on the left-hand side the storyboard item. These are actual storyboards, outlines of them, lesson outline. And you can see that the items are the same, but going across on the instructional content, the graphic suggestions, and assessment methods change based on the variant. So next we took and we said, okay, we're going to take these high-level topic outlines and then generate detailed lesson design documents with specific recommendations for content, media, and assessments that were tailored to each course variant. And these examples you see here are one of the basic and intermediate levels. The process showed how large language models can move from broad instructional outlines to detailed lesson plans. And you can see, again, how the content, media recommendations, and assessment methods were generated with contextually relevant data and then aligned to the appropriate learning objectives. Then finally, we took the previous two, the lesson and the topic outlines, and we generated specific storyboard content and narration at the page or screen level. This output saved an enormous amount of time while delivering high-quality, relevant instructional materials for multiple learning levels and ratings. You'll see on the right-hand side, it also was able to generate narration and closed captioning text that could be ingested very easily. Bob.
Okay, so there are barriers and challenges to creating applications based on generative AI. Now, everyone out there is already creating applications, and that can be a problem. There's a lot of research going in now to making sure these models are accurate. So as an example, so I've got a bulldog at home, sweetest dog, so great with kids, everything, but dumb as a rock. If I throw a tennis ball, it is going to come back with something. It is going to fetch something. Half the time it's a tennis ball, the other times it's a rock, it's a stick, it's a bone, something. But it just wants to please. And that's how I view large language models now. They want to give you an answer, and they will give you an answer. And sometimes, a lot of times, it's going to be the wrong answer, but it's going to happily be very confident and give you that answer. So you have to be very careful about trusting the output. Bias in those responses too. Even if it's correct, if it's exposing systemic bias within the training data, it can be a big issue. I wrote a paper a couple years ago that looked at job placement. So, based on, if you ask, at that time at least, if you ask ChatGPT, what would be a good job for someone from Sweden versus someone from Mexico, and I won't go into it, but it would give very wildly different responses given only that information of country of origin, nothing about their skills, abilities. And so, if you just take these models out of the box and use them to match people to jobs, you're gonna, reproduce those biases that may have existed for decades out there. Scalability is another consideration. So deploying, you may want to use the best model out there, whether it's ChatGPT or Claude or something that came out this morning that I don't know about yet. But you need to choose, as I said earlier, the right model for your project or for your application. And a lot of this comes down to computational resources. These things are not cheap to run, not cheap to train. So understanding, what is the right level you need. GPUs are very expensive. We're, going up against things like Bitcoin, which use GPUs to literally create money. So they're not cheap, and they're in high demand now for AI applications. Integrating into existing systems and workflows can be very difficult. And understanding how to get access to the right data at the right time. And latency. I stated this earlier, but sometimes you need a response instantly. If you're building a LLM to help an aircraft pilot get out of a situation, you don't want to wait 3 minutes for the response from it. And God, I hope we're not building that application. There's also a lot of organizational challenges. So not just technical barriers, but organizational barriers. LLMs and other generative AI, this word gets thrown around a lot, but it's true. They're disruptors. They are disrupting the way we work right now. And we have to figure out how to integrate these into the workflow so that people still have jobs, that we can trust these systems, that we can accept their responses, know that they're providing accurate information. And people are going to be reluctant to change. So we have to find ways to integrate these in and find the best way for people to use them in their jobs. There's also a skill gap. So a lot of these applications, you really need to train staff to effectively use large language models and other generative AI, again, to kind of reduce all those problems we've talked about. And every business has different processes, and so adjusting those processes to adapt to these new workflows so that those efficiencies that you want to create can actually be realized. There's also some some cost in here, monetary cost. So initial investment, so it can cost a lot, especially if you're going to do things like training. Just the electricity to run the training can cost a lot of money. And maintenance as well. So depending on the demands of your application, if you need your large language model to be available 24/7, have low latency, that's going to cost more than a offline model that only runs when you need it, for example. Collaboration is something else to consider. So if we're all using the same language model, we need to understand, is it going to give different responses for me versus my colleague, based on different prompting or different data that I send it. So being able to efficiently collaborate with these models and with other humans is going to be key. And then, just stakeholder buy-in. So there's a lot of resistance to these, and sometimes there should be resistance. But making sure that everyone that's going to be affected by these models, by these applications, are kind of on board and know how it's going to affect them. There's also a lot of security challenges. So the first one to think about is privacy. So you need to be very careful about what information you send to large language models, especially ones that are hosted out there on the open web. So for example, if I'm using ChatGPT to help me write a report, I'm okay kind of giving my bio to it, because it probably already knows that. But I'm not going to put in proprietary company financial information out into ChatGPT on the web. They say that they keep it safe and secure, but we all know that leaks happen, things happen, and people have actually reverse engineered prompts to get supposedly private information out of large language models. So be very careful about what you send to it. There's also a lot of compliance. So as we begin to integrate these, especially with government applications, we need to be able to comply to the regulations that exist and future regulations. So understanding what safeguards need to be in place to protect privacy, protect the data, very important. From a cybersecurity standpoint, there's a lot of potential vulnerabilities, so you need to be able to protect these systems from malicious prompts, if someone gives you a language model to run in your ecosystem, you want to make sure that that model is not going to all of a sudden start sending SQL injects into your database to corrupt your data. So you need to be very aware of a lot of the security and vulnerabilities in your own ecosystem and new ones that may get introduced once you start bringing generative AI into it. Access control too. You want to make sure you manage who has access to these models and be able to restrict that when necessary. And then ethical concerns too. Transparency. AI. I think I encourage people to use AI, but I encourage people to be transparent about it. Saying that I wrote this, but in collaboration with ChatGPT, it helped me to summarize information, et cetera. And then there's also kind of more ethical concerns in terms of accountability. So if an AI system gives a wrong answer and it costs someone's life, who's accountable for that? Is it the person that built the application? Is it the person that was using it? Is it OpenAI? Is it the person that created the data that trained it? So there's a lot of considerations too about ethics here. Okay, so the future of AI LLM. So the future is today, because this is a very active research and development community out there building these systems. But we see kind of very exciting applications on the horizon. So adaptive learning, AI systems that can tailor content on the fly to the individual at the right time and provide real-time feedback to that individual in a personalized way that helps them learn. Next generation LLMs, they're going to be more powerful, they're going to be more efficient, they're going to run on your phone, and they're going to be way beyond text. They're going to be generating images, they're going to be generating songs. They're already doing this. Pretty much any modality of data out there, there's going to be a generative AI model that can create it or understand it. In terms of automation and efficiency, using AI to generate entire training modules, assessments, so, based on this person, how they answered, previous questions, let me figure out what to ask them next to really assess, do they understand this concept? So being able to do that on the fly is very exciting. And then smart workflow management, optimizing kind of very complex training workflows so that we can create more efficiencies in the end. Okay. In terms of other application areas, so we've talked a lot about military and defense. Being able to create training for new systems, revamp training for old systems, provide real-time support during operations. I think we're all moving in this direction. In the healthcare sector, virtual patients to help doctors learn, simulating medical procedures, simulating how people respond to questions about their own health to help doctors train, and then using these tools to help diagnose new diseases, to help understand kind of the way proteins interact in different environments, and to synthesize new drugs, things like that. Corporate training, helping with skill development, so personalized upskilling and reskilling programs for employees. Leadership training, so coaches, AI-based coaches that can help people develop their leadership skills. And then even in education, so elementary, all the way from kindergarten, through high school, college. AI tutors kind of providing personalized learning experiences for students across the board. And back to Ramona.
Okay, we're almost ready to wrap up. I'm going to summarize a little bit. So let's talk about the elephant in the room, everybody. Human expertise is still critical. We are not looking to replace humans. We are looking to augment humans, make it easier. My motto is work smarter, not harder. So we can use these systems to help. We do need to focus, we need humans to focus on those strategic aspects of the job, the things that humans do best, the logic, the higher order thinking. But it can offload a lot of information, a lot of work, and a lot of tasks to AI. I wanted to leave you with a couple of different ways that it can assist ISDs. Most of this was about training and development, so I'm assuming a lot of you are here in ISD positions. But content generation, idea generation, scenarios, it can help with that. A lot of people don't have that creativity in there, okay, but it can help you with that creativity on some things. Curriculum development, a lot of that work is kind of rote. You take a paragraph out of a textbook and you make content from it. AI can do that really well, actually. Looking at adaptive learning paths, kind of like the one I showed earlier, the case study, adapting to different roles and different responsibilities, and then taking the same base content but elevating it to different levels. Content refinement and idea collaboration. So these are just all different ideas of where you can use it. Some other things is like personalization. Everybody, we've been talking about personalization for decades now. I don't think we're still there yet, but maybe this will help get us even closer. We talked about multimodal learning, looking at it, making videos for us and audio and things like that that are very time consuming to do now and very costly. So again, saving us time and also learning analytics. Being able to use AI to look at predictive analytics of how they're doing in their training, where should they go next in their training, what experiences are they doing well at, what experiences do they still need to master. So those are some good things to look at there. Again, these were our learning objectives. Hope we accomplished these for you. We do have references. And thank you. We are open for questions. Yes.
Do you have any recommendations for integrating LLMs on closed systems?
LLMs on closed systems, recommendations? He's the engineering
So
guy.
I would go, so probably the biggest open source one now that you can bring into your kind of a closed ecosystem would be like Llama. That's from Meta. If you go to Hugging Face, though, there's tons of different models there. And again, you need to make sure that you're getting the right size model for your kind of constraints of that system, both kind of hardware and software.
Yes, sir.
First of all, thank you very much for an excellent presentation.
Thank you.
Felt like you were speaking to me directly the whole time.
I was. You didn't see that?
Learning the AI work.
Thank you.
Look, you talk about data sensitivity, and sometimes I think we underestimate the fact of data that can be aggregated over time. And I worry about, uploading, 50 or 60 training plans from our military, and then it having all that individual information, and someone being able to reverse engineer like a gap in our capability. So, any comments on that?
I mean, that's a huge concern. And I think that's why you're seeing, the government is slow in rolling out the use of large language models. We're starting to see some like Camo GPT come online that are kind of in a closed environment, have access control. And I think for anything like sensitive information, whether it's government, military, business, proprietary business information, that's something you have to consider. I think we are going to see a lot of people going to closed models for any sort of application, that has sensitive data in it.
One thing I did not really mention in the presentation, but SME knowledge elicitation has been a huge issue for years. People roll out, they retire out, they take that subject matter knowledge with them, that expertise. And one of the things as a longtime ISD that I'm looking at is when we go through and look at these answers and we get feedback from SMEs about the relevancy or not relevancy or the trustworthiness of the information, all of that gets put into databases that would be behind, the firewalls. But that is actually going to be a way for capturing and maintaining expert knowledge. And I think that's one thing that's kind of been overlooked as far as a benefit. Yes, ma'am.
Along those lines, we're considering a closed LLM for that purpose because, we get an abundance of feedback and stuff from our SMEs.
We is,
So, sorry, I work for the government. I work for FDIC.
okay, FDIC, okay.
And so, we have an abundance of SME knowledge and so on.
Yeah.
And so forth. But, one of the things that we're considering though is that we have an LMS that has, web-based training, score packages, all of those other things in it, in addition to our SOPs, our manuals, all of our other knowledge. And so one of the things I'm looking at is whether I can do an API from my LMS to a closed network LLM and how I can bring my data to that. So I haven't looked into it really closely yet. I'm just
Yeah.
at the beginnings of it. But have you had any, have you looked at any of that? Have you
Yeah.
had a chance?
Absolutely.
Yeah. So, both for applications at our own company that we want to build that, we want to be able to look at our own data, which we don't want to send out there to OpenAI or any other third party, to highly classified top secret data. It's going to necessitate having models like Llama 3 I mentioned, Mistral. So these are all models that, you can run locally on your own hardware. You can fine tune. Now, these processes are not easy. They require some expertise to get them up and running. But there are models out there that, especially for very specific applications, can be fine tuned and run locally. And there's more coming out every day.
Okay.
Yeah.
To take an LMS and basically kind of like without further words, backdoor from a cloud basically to an a closed network LLM
Yep.
to pull your data and then text extract all of your other manuals and everything else in the right format that you want.
Yep.
Build in and close it so that all of your feedback and everything stays internal.
Yeah, so I'm not a software architect, but yeah, so I think you can like, you can pull data down and then, keep it within a firewall. So you make sure that any of the derivative data doesn't get back out there, basically. Yeah,
I'm not an architect either. I mean, that's what we've been looking at is
yeah,
just the dynamics of it because, like most of the concerns I imagine in this room is the same, is that, ChatGPT and all these other things are great, except for they're open.
yes,
And like Eva said, the last thing that any of us want is just a little glimpse of any information, even if it's just somebody's, scores of something. You
yeah.
just don't want it to go anywhere.
Yeah, no, and I think, as we move from just kind of novel, fun applications of ChatGPT to actually using it for business intelligence or government intelligence, what have you, we're going to see a lot more solutions out there. I mean, one of the things I like to say is like, oh, wouldn't it be, if I'm ever thinking, wouldn't it be cool if ChatGPT could do this? Usually the answer is wait 6 months and it'll be able to do that. So it's a very rapidly evolving field out there.
And so from the instructional design side, I'm looking at this going, okay, you take that information from the LMS. Usually now an instructor is looking at that and taking, performance metrics and seeing how they're doing. But when you take and you add AI into it and they can then determine where the remediation needs to happen, point directly to lesson material because it's got that database of all the lesson material. It knows where the content is. If they're a mastery of a competency, it knows all of the parts of that competency that they may need to remediate on. So there's a huge power in that, and getting to mastery and to better qualified, better trained people much quicker than if I have to pour through a lot of data, try to make sense of it, try to figure out which lesson that they need to go back to and work on. So those are some huge things. And then you take that and combine that with years of doing this and the repositories that, we all have repositories and media repositories that we built over the past 20 years. So that's what we're doing is basically building a new repository of information or ingesting other repositories that can be leveraged with some of this decision making.
Well, and I'm an ISD by trade. I was DOD and I was prior military, so I was a contractor for years, and
Yeah.
so I've been a jack of all trades here, and so I've seen all of this.
Yeah.
And so your example of TDC, all of those different things,
Yeah.
I mean, I've lived it. So,
Yeah, me too.
Yeah, exactly.
Me
So,
too.
I mean, yeah, so this all speaks,
That's why it's been exciting to me as an ISD because I can see like all of these decades of myself working in different Navy, Army, Air Force, whatever, everything. I can just see the extensibility of this and how it's going to leverage over the next 5 years, for instance. So.
well, exactly, and the things that I know was all working with software engineers and everything over the years that have showed me things, and I'm like, whoa, wouldn't it be nice if we could do this? And then now it's all, like he said, it's evolving around us.
Any further questions? Sir, you were fast. Go ahead.
Thank you. Lieutenant Colonel Carey, U.S. Air Force. Talking about some of the challenges that you talked about in the career, how can an LLM user, what measures of performance can I look at to try to assess things like accuracy, bias, explainability of a model so I can assess its trustworthiness?
Yeah, that's, again, another rapidly evolving field because as people are beginning to apply these, they're realizing that, oh, I need to actually assess this before I just throw it into an application. So there are starting to be frameworks out there, and there's a lot of research into measures and metrics of accuracy, reliability. It becomes harder because you're not generating a numerical value that you can check against reality. You're generating a textual response. So a lot of the ways we evaluate human responses are going to evolve to be how we evaluate large language model responses. So again, there's things you can do like creating ground truth data sets so that you can test to see like, okay, did the response match the response here? And it's another thing, you can use LLMs to actually do the evaluation. So give it its own response, give it the correct response, and say like, how accurate were you in assessing this? So
Again,
Yeah.
as the ISDs review the data that produces for training elements, as the SMEs do it in the fleet, and they look at it and see, oh yeah, that's on board, yeah, and you go approve, approve, approve. Again, that's building intelligence in the system. So me as an ISD, you have to learn whatever it is that you're gonna teach. I have to learn how to take bomb rack, you know, I know when you're supposed to call QA in. Those are things that, you know, as we feed the system feedback on the responses, it will grow and learn and be more accurate over time as well. Sir?
I have two questions. The first one is the examples that you demonstrated over
Uh-huh.
what LLM you use to generate those training
Which LLM? We use Llama and ChatGPT.
internally?
Yeah, no, those were public facing. They don't have, well,
Yeah.
the Llama, we do
The
have
Llama
a
was
hosted-
internal.
We do have an internal hosted Llama.
Yeah.
But the other one was, and it was not sensitive data at that time. And so we're currently working on that with still non-classified, non-CUI data right now, until the Navy gets, their LMS or something behind a firewall that we can go full out with.
And there are Azure government cloud instances of ChatGPT, the latest models that are, you verify this information before you go out and use them, but I believe they are okay to like use CUI information, so controlled unclassified information on. But yeah, anything within a closed environment, you'd have to host your own model.
So there have been instances where the non-classified is told access or non-sensitive.
Yeah.
Use over agile.
Last question?
Yeah, did you ever try to modify the answer to the prompt before it reaches the prompter? So,
Can you give me a specific example or?
can I be sure when I send the prompt to the LLM that the answer is actually from the LLM and not from someone in between?
Oh.
So,
A third party hacking in, monitoring
another
or?
LLM, I don't know.
Yeah, so that's a great question. I haven't considered that. So if someone, basically taking your prompt and acting like an LLM and providing you incorrect information. So yeah, I don't currently know how to verify whether a response actually came from a language model, but that's an interesting problem. Yeah, thank you.